Guys, okay, week 7 mechanics CA. It's really copy paste like the periodic, most of it except like 2 questions. So just fly through it. The first time graph of two moving objects denoted by I and I below. Okay, so the answer is I has a higher acceleration because acceleration is a slope and it has a steeper slope. All the other ones are wrong. In a 3 kilometer run, Sam covers distance the first 1.5 kilometers at a speed of 0.6 kilometers per hour, and then the second 1.5 kilometers at 0.8 kilometers per hour. Now this one, he covers half the distance at 0.6, the other half is 0.8. Logically, you can do it in your head, it's going to be 0.7. But like, let me explain. So you can do it 1.5 over 3 times 0.6. The distance over the whole thing times, oh, it says 6. Plus 1.5 over 3 times 0.8. You get 0.7. Motorbike rider moves along a straight road due north for what should be a 300 kilometers trip. She covers the first 110 kilometers in 50 minutes, then backtracks 50 kilometers in 20 minutes. Sees her friend after seeing her friend. She continues her journey to finish it in 170 minutes. Now here, this question's a bit confusing, so I'll just draw out what's happening. 110 kilometers in 50 minutes. 50 minutes. And then backtracks 50k in 20 minutes. And then goes up, finishes the rest of her journey all the way to 300 in 170 minutes. Now, we need to find this. Like, first of all, we need to find how long this is. So this whole thing, all of this is 300. So 300 minus 110, minus 110, because this bit already went up, plus 50 because she went back down. So you're gonna get this part is 240. So she traveled at 240 in 170 minutes. I know also the 170 minutes seems like she finished the whole journey in 170 minutes, but no, they mean it. Okay, so distance covered. So 110, you add them all up, plus 50, plus 240. You get 400. The displacement is 300 kilometers to the north. Displacement is vector quantity, so you need to put magnitude and direction. Her average velocity, okay. So it's going to be displacement over time. What's that? It's going to be 50 minutes plus 20 plus 170 minutes, but they want it in kilometers per hour, so you're going to divide by 60. You're going to get 75 kilometers per hour. And they said velocity, so it's 75 kilometers per hour to the north, because velocity is vector. If it's speed, then it's just 75 kilometers per hour. At speed, it would be distance over time, not displacement over time. So you'd use the 400, not the 300. Okay, a particle moves along a straight line where it's positioned from the origin by the equation x equals 4t squared plus 3t minus 5, where x is expressed in meters and t in seconds. Write all the answers to two significant figures. Okay, the displacement of the particle between t0 and t equals 3 seconds. Displacement, so I'm gonna find x final, so x final is gonna equal t at 3 seconds, so it's gonna be equal 4 times 3 squared plus 3 times 3 minus 5. That minus, no, let's just find x initial. X initial, you just tell it's gonna be negative 5 because this is gonna be 0, so 4 times 0 squared, so it's gonna cancel, it's gonna be 0, plus 3 times 0, it's gonna cancel, it's gonna be 0, minus 5, so it's gonna be negative 5. So x final, let's find x final. 4 times 3 squared plus 3 times 3 minus 5. X final is equal to 40. X initial is equal to negative 5. So 40 x final minus x initial, which is equal to negative 5. So minus 5 is going to be 40 plus 5, so answer 40 equals 45. Average velocity. So it's going to be displacement over time. Displacement is 45. We got it in the first in part A. Over time, 3 minus 0, 0, t final minus t. So 45 over 3 equals 15. The velocity of the particle at t equals 2 seconds. Okay, look. Velocity from an xt graph is the slope of the graph. Now here they don't have the graph, but they gave you the formula, so you can just derive it to get the slope at like a certain point. And also the slope of the velocity is gonna give you the acceleration. So first let's derive this. It's gonna be 8t plus 3. T is equal to 2 seconds, so 8 times 2 plus 3. It's gonna be 16 plus 3 is gonna equal 19. So velocity at t equals to 2 seconds is 19. Acceleration. So acceleration, they want us to derive this again. So if we derive this again, it's gonna give us, it's just gonna be 8. And t doesn't change because there's no t also in the graph. So no matter what happens to t, it's gonna stay 8. So the acceleration of the particle at any instant is 8. Average acceleration. So average acceleration is the secant. Instantaneous acceleration is the slope of the tangent. So here in the first 5 seconds, so they want you to find the slope of the secant from 5 seconds to from here basically to here. No need to draw the secant, you can just use the 2 points. So delta v over delta t. So v final is negative 1 minus v initial, which is 2. So negative 3 over t final is 5 minus minus t initial, which is 0. It's gonna be negative 3 over 5, so equal negative 0.6. Negative 0.6. Okay, then this question speeds up. So if it's positive, you get a positive. Okay, if it slows down, so negative times positive, you get a negative. And then speeds up, so positive times negative, you get a negative. If it's negative, you get a positive. Okay, if you multiply positive, you get positive. Yeah. Okay, so a bicycle speeds up in the positive direction, so positive is greater than 0 because it's positive. Here it's going to be less than 0 because negative positive. Here it's going to be positive negative, so it's going to be also less than 0. Slows down the negative direction, so negative, so is greater than 0. velocity of truck A. Okay, so how do you find velocity from xt graph? It's the slope. So the slope is from, we'll use this point and this point. Okay, x final, so 4 minus 3 over 2 minus 1. 4 x final minus x initial 3 over 2 t final minus t initial 1. You're gonna get 1 over 1. So the answer is 1. Now, part B, we're gonna use these 2 points. We're gonna use this point and this. So 5 minus 3 over 2 minus 1 x final minus x initial over t final minus t initial. So it's gonna be 2 over 1. So it's gonna be 2. Meeting time, the time when they both have the same position, so it's 1 second. The time, you just see where they intersect and you see the seconds. And meeting position, you also see where they intersect, where they meet, and you go together 3 meters. The remote control car is at momentarily rest when t equals 5 seconds. It's gonna speed up, stop momentarily, and then like go in the opposite direction. It doesn't speed up anymore. It just goes to the positive direction, stops, and goes down. It's at momentary at rest 0.5 seconds. Between t equals 0.5 and t equals 0, the velocity of the remote control car. So this one I got wrong when I was solving it. They don't want the velocity, they just want if it's positive or negative, and it's going down, so the slope would be negative, so it's negative. If it's going up, then it's positive. The average velocity of a remote control car throughout its motion. So here they want slope of the secant between this point and this point. You don't need to draw the secant, you don't need to do all that, you just need to see the points and you do it. Okay. X final is 0 minus x initial is 0.5 over t final, so 2 minus 0. Negative 0.5 over 2 equals negative 0.25. So the answer is negative 0.2. UARM causes the VT graph to be linear. UARM means acceleration is constant. And if acceleration is constant, then the slope of the VT graph is constant, which means it would be linear. It wouldn't be a curve. So acceleration. Okay, this question, it's going down steep. It's the steepest part, and here it's 0. So I thought 0 would be the highest when I was solving it, because these are both negative because it's going down. But I guess they want the magnitude even though they didn't say that. So which phase has the highest acceleration? It would be 2. That's the steepest. The time interval where the toy car is at rest, so its position doesn't change. It's the first one because it's flat. So it's 0 seconds to 3 seconds. 0 seconds. The farthest point the toy car reaches from the origin, this is the origin, the farthest point is this one. So it's at 10 meters. Net displacement of the toy car, x final minus x initial, so 10 minus 6, so 4. Each box is 2. 10 minus 6, yeah. The total distance traveled by the car. So the total distance, you're gonna find the distance of each segment. So this segment by itself, this segment by itself. Each segment you need to solve it and add them up. So the distance of the segment is x final minus x. Yes. This one's 6 minus 6, so 0. Despite this one is 0. So this segment, it's 0. This one, it's gonna be negative 4, minus 6. And they want the absolute value here because it's distance. And distance can't be negative. Okay, so this segment, it's 0 minus negative 4. What that? 0 minus negative 4. So 0 plus 4 is 4. And this one, it's 10 minus 0, so it's just 10. So absolute value of negative 4 minus 6 is 10. So this part's 10. This one's 4. This one's 10. So 10 plus 4 plus 10 is going to be 24. The toy car is at the origin at instances. Okay, just see when it intersects the origin. So it's 6 seconds and 13 seconds. 6 seconds and 13. Okay, the magnitude of deceleration of the bicycle in the second leg. Okay. The first leg of motion, a bicycle accelerates from rest in the positive direction at 1.5 meters per second squared at 6 seconds. So in the second leg of motion, the bicycle decelerates a full stop in 5 seconds. Okay. So the way you find deceleration is V final minus V initial over T final minus T initial. Okay. What's V final? 0. Okay, stop. Minus V initial. We don't know it. We need to solve it. Okay. So AT equals V final minus V initial. It's V initial of the first leg. So AT is 1.5 times 6 is 9. So and V initial is 0 because it starts from rest. So 9 equals V final minus 0. So V final is 9. So here, so V final of the first leg is going to be V initial of the second leg, because the end of the first leg is the start of the second leg. So V initial of the second leg is 9. T final, so 5 seconds minus T initial. Negative 9 over 5. It's going to be negative 1.8. So the acceleration is negative 1.8, but they want the magnitude of deceleration. So it's 1.8 here. Okay. Okay, this part is the same as the question that was at the start, because positive, positive, so it's positive. Negative, positive, so it's negative. Positive, negative, so it's negative. Negative, negative, so it's positive. Positive greater than that. Which runner won the race? The runner who won the race is the one who completed it in the least amount of time, so Albert. And which runner stopped for rest? Charlie, because his graph was constant. Yeah. It's flat. The average velocity of the object in the time interval 1 second, 3 seconds. Okay, so they want between 1 second and 3 seconds. So x final 6 minus 1 x initial over t final minus t initial. So 5 5 over 2, so it's going to be equal to 2.5. Okay. The graph below represents the VT graph of a particle. The equation of its velocity is V equals something t plus 0. So this, it's going to be the slope, and this is the y-intercept, where it intercepts the y-axis. So that's 2. Just intercepts the y-axis at 2, you can see the graph. And the slope is v final minus v initial. So we're going to use this point because it's clear, and on a this point because it's also clear. So 12 v final minus 2v initial over 4 minus 0. So it's going to equal 10 over 4. It's going to be 2.5. The instantaneous acceleration at t equals 1 second to do decimal places. So they just want the slope of this line, the slope of the tangent. So we're going to use this point and the point they gave us, which is at 1 second is 1 meter per second. So v final is 10 minus v initial is 1 over t final is 5 and t initial is 1. So it's going to be 9 over 4. If you put that on the calculator, you get 2.25. 25, and they wanted to do decimal places, so it's 2.25. Okay. A toy car is constrained to move along the straight track PQRT. Assume that the car can change its direction of motion very quickly due to varying quality of the track. The toy car can move along different segments of the track at different speeds. The following data about the time necessary to cover each of the track segments has been collected. Average speed, so distance over time, so distance, so PQ, distance over time, so PQ is 10 plus QR is 20 plus RT is 40 plus TR is 40 plus RQ is 20. Add those up again. Let me just do it on the calculator. 2 seconds. 10 plus 20 plus 40 plus 40 plus 20. You get 130 over time. So over, what's the time gonna be? 5 plus 10 plus 18 plus 12 plus 10. You get 55 plus 10 plus 18. So 130 over 55 is 2.363. 2.36. The magnitude of average velocity, so it's displacement over time. So it's gonna be the final position minus the initial position. I mean, yeah, displacement. So the final position is Q. So the distance from P to Q. So from P to Q, it's 10 meters. So it's 10 displacement is 10 over time is 55. So what's 10 over 55? 5. Just do it on the calculator. You get 0.18. It's repeating, so just put 0.18. I want to do this 0.18. Okay. In which segment is the instantaneous speed the greatest? So the answer is TR, because if you do distance over time, here it would be 2, here it would be 2, here it would be like 2.2222, here it would be also 2. So this one's the greatest because it has the greatest distance with like less time than the other one that has 40. You can calculate each one of them, but it's gonna take too long. The motion of the glider is uniform in the time interval, so it increases by 3 seconds in the time. Let's see. So the first time interval it increases by 3 seconds. I mean, it moves 3 meters per second, and then 3 meters per second, and then 3 meters per second, and then 4, and then 5 meters per second, and then 9. So when is it constant? From 0 to 3. Yeah. The speed of the glider, so it moves 3 meters per second, 3 meters per second. It's gonna be 3 meters per second in interval 0.3 seconds. So 3, because they want it in the interval, which is this one, the first 3 where it's constant. Okay, this one, position is location with respect to the origin. Average velocity is displacement over time. Model is a simplified assumption like the particle model. Distance over time is average speed. This question is the exact same, like literally the same graph, and it's all the answers are the same as this question. Yeah. So I'm not gonna do it again. If you want, just go back in the video to where I solved this question. So I just skip this one, it's the same as that. Okay. At the moment of time when the particle is instantaneously at rest. So again, the local maximum and the local minimum, where it's like flat, it's going in the positive direction, then going in the opposite direction. So at this point, it's when it's at rest. At t equals 11, the instantaneous velocity of the particle is, okay, so t equals 11. So at this point, the instantaneous velocity of the particle is something else. So you would find the slope of the tangent at this point because it's a curve. But actually, in the question, this part, this end segment, it's a straight line. It's not clear at all. I know this question is not that clear. But yeah. So X final is this. -12 minus 0, because it's at the origin, so it's 0. T final is 13 minus 11. So it's -12 because it's down. So -12 minus 0, it's gonna equal -12 over 2, so it's -6. And this instantaneous speed is the magnitude of the velocity, because it's just the magnitude. It doesn't have the direction. The particle is instantaneously at rest at, this one's a VT graph, so it's not when the slope is flat. When it's flat, that means acceleration is equal to 0. It's at rest when velocity is equal to 0. Here in the VT graph is when it intersects the origin. So it's at 8 seconds and 13 seconds. 8 and 13? Yeah. The instantaneous acceleration of the particle at t equals 5 seconds to 1 decimal. So they want the slope of the tangent. So we'll use this point and this point. V final is 0. V initial is 7. And T final is 12. And T initial is 1. So negative 7 over 11. Negative 7 over 11. I'll put it on your calc. Negative 7 over 11. Negative 0.6363. Negative 0.62 on this. Okay, this one I didn't solve it.